bring up materials and analyze it to see if there's organic matter, organic meaning related to carbon compounds, but specifically ones that might have been created by life. So that's very exciting. And then in 2020 is our next big NASA rover following on Curiosity that will actually collect samples so that eventually we can bring them back to Earth, put them in our best analytical instruments and see if we see any signs of ancient or conditions that would tell us that there's life on Mars. That's just the beginning. That's just in the next 5 years. You know, beyond that, we have lots of plans as part of our journey to Mars that include developing the Space Launch System, a big rocket that will better in the future be able to get payloads to Mars and perhaps a round-trip mission. And we're still sketching out what that looks like. The future is always more fuzzy than the current, but certainly these exciting results only encourage us for the future of Mars exploration.
We also shouldn't discount what we currently have as assets that are there. They're actually relatively healthy. The Mars Reconnaissance Orbiter is doing a fabulous job. It's got high-resolution imaging, and as we talked about, the mineralogy from CRISM that it's been doing. You know, when you look at, even though it's been there nearly 9 years, it's only really mapped about 3 or 4% in high resolution of Mars. There's so much more that we need to do to really look and understand this kind of network all over the place. And with that, it'll enable us then to narrow down on some better places or more accessible places where we can get access to these kind of regions to really thoroughly examine. Curiosity is also in a nice location. It's in Mount Sharp. It's doing great. There's potentially some dark streaks that are on Mount Sharp. We don't know much about those. We don't know if they're reoccurring slope lineae. There's a possibility that more observations will eliminate those or give us more data that could tell us that they also could be RSLs that we might be able to visit. So there's some really exciting things just coming up, even with our current assets.
One more question and then we go to the phone line. Sir?
David Curley from ABC News. John, let's talk about astronauts. This really is a breakthrough for human travel to Mars. You could now purify the water, create oxygen. This makes it much easier, doesn't it?
Well, I think all of the scientific discoveries that we're making on the surface of Mars, at Curiosity at Gale Crater, these observations from Mars Reconnaissance Orbiter are giving us a much better view that Mars has resources that are useful to future travelers. When you have water, you know, what's water? Hydrogen and oxygen. That's what we make rocket fuel out of. Perchlorates. The space shuttle, the solid rocket boosters are aluminum perchlorate. In principle, you could make solid rocket fuel. And as we've talked about, perchlorates are ubiquitous around Mars. But the water really is crucial because we need water to drink, oxygen to breathe. We have carbon dioxide, also oxygen. So there are plenty of resources on Mars, even nitrogen in the atmosphere, which we don't usually think about because for us it's relatively inert. But it's crucial for life, both if life exists on Mars, but also, you know, once we get there, we're going to need nitrogen for a variety of purposes. So I think, you know, Mars is looking more and more that, you know, it's a potential habitat for extant life on Mars that could be, as you heard, you know, from transfer from Earth one way or the other. You know, some people say we're Martians. It could go either way. But the exciting thing is that I think we will send humans in the near future to Mars. There'll be scientists looking for signs of life. And also to be able to live on the surface, and the resources are there.
I think it's important to realize that NASA's approach to exploration is not Star Trek. It's not go where no man has gone before, as they say. It's really a very methodical approach for which we learn everything about the environment that we're going to subject humans to that we possibly can. And that's why our rigorous scientific program is really the pioneers that are making steady discoveries. And I anticipate continuing to do that for many, many years before humans even get into the vicinity of Mars. We'll make rapid progress in these areas. That does indeed help us understand the parameters and design better missions, leverage and utilize the resources that are available, and even make those kind of trips more feasible in the future than ever before.
In fact, I'll be very specific. On our Mars 2020 lander, we have an experiment that's not a classical science experiment. In fact, it's a in situ resource utilization experiment. So you may hear that. You know, we love our acronyms, ISRU. But it's a small apparatus that's going to take in Martian atmosphere, mostly carbon dioxide, and extract the oxygen. And that's its function. We know we can do that on Earth, but we're going to demonstrate it on Mars. And that's, part of, our combination of human spaceflight, space technology, and science all in one.
Find us on Facebook at facebook.com/ETNow, and don't forget to click the like button. You can also follow us on Twitter at ETNowLive. To stay updated with all our programming, hit the subscribe button on our YouTube channel by logging on to youtube.com/user/ETNow.